Hi everyone. In today's lesson I'm going to tell you about how to go from standard form to vertex form, and the strategy that I'm going to tell you about today is completing the square. Okay, so let's say that I'm starting with something in standard form like this, and I would like to factor it. So if I do that, it's been a while since we've done factoring, so this is a good practice anyway. So if I do that, I am going to take, if you recall, my x squared term and put it in the top left corner. Now, just for this first example, I'm going to draw it out using tiles. So here's my x squared tile. That one goes there. And the second thing that I'm going to do is I'm going to take my 9, the last term, and I'm going to draw it in the bottom right-hand corner like so. So I should have 9 in here. There we are, 9. Okay, so 9 units. And then I have to take my 6x and put some of them here and some of them here. And you can probably see already where this is going. I have to have 3 x tiles like so. So there's x, 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 and 3 x tiles over here. X, x, x. And here's my 9, of course. And so then, now that I've taken all of my tiles, I can write down the factors by reading along this side. So this is x plus 1, 2, 3. So this is x plus 3. And I do the same thing along here. X, 1, 2, 3. This is x plus 3. All right. So the reason why I use tiles here is that I wanted you to see that this is a square. Both of the sides of this figure have side length x plus 3, x plus 3. So since the two side lengths are the same, even though they have a variable, the two side lengths are the same, so this is a square. All right, and if I'm writing this in factored form, this can be written as x plus 3 squared. So the fact that there's a square here is another indication that my that I have a perfect square. So whenever you're able to take a quadratic in standard form and just reduce it to something like this, where you have a single binomial but it's squared, this is sometimes what's called a perfect square. Okay, so let's try one more example. So here I have x squared plus 4x. And I'd like to factor this in the same sort of way. I'd like to factor this into a perfect square, if possible. Well, if I start off, I'm going to make my box. And so this time I'm not going to use tiles, so I hope that's okay. So in the first box, I'm going to write x squared. There's my x squared term. I don't have any unit terms, right? There's a 0 here. There's no unit terms. So what I'm going to do in this case is I'm going to put 2 of the x's here and 2 of the x's here. So when you're trying to write something as a perfect square, you have to take the middle term, or the b, the linear term here, and put half of them here and half of them here. That's always the way you do it when you're trying to get a perfect square. But of course I don't have a perfect square, right? This thing here is missing. Well, okay, let's just proceed as if I did have that. So in this case, if I were factoring, I'd have an x over here, I'd have an x over here, I'd have a 2 over here, I'd have a 2 over here. And you can see now that the deficit, the term that I'm missing, is 2 times 2, or 4. So I need a 4 here. So what I'm going to do is I'm just going to add 4. I'm going to add 4, but since I've added 4, I have to subtract 4, otherwise I've lost my balance. So in this case I'm going to add 4 in the box, and then I subtract 4 outside of the box. And now watch what happens. Now my box is complete, right? My box is complete and I have this perfect square here. So this becomes x plus 2 squared minus 4, right? The minus 4 from here just comes down. And now what does this remind you of? well, I hope it reminds you of vertex form. This is how we go from standard form to vertex form, which is to say that we're completing our square, right? We started with something which was not a perfect square, and we took our original standard form, we factored it into something that wasn't a perfect square, we added on the deficit so as to make a perfect square, but then subtracted the same amount so that we don't lose our balance. And then the perfect square turns into this, and then the leftover bit just gets written next to it. So in this case, you can just, again, read your vertex. So this parabola, if we were to graph it, would have a vertex at -2, -4. Okay, let's do one more. So in this case, we have, again, I've been trying to choose fairly simple quadratics, ones that are easy to factor. So if we do that, oopsie daisy. So if we do that, again, we have x squared here. Our strategy is always to take our middle term and split it into 2. So we have 5x here, 5x here. And again, you only do this when you're trying to complete the square. So just kind of a specialized application of factoring in a way. We factor this, so we have x plus 5 plus 5. And so since we have 2 down here, that's not enough, right? Because 5 times 5 is 25. So we're missing quite a lot. We're missing 23. So we've got to add 23 here. That's our deficit. But then we have to subtract 23 so that we don't lose our balance. All right? And so now we can write this out. Again, we have our perfect square, x plus 5 squared minus 23. And once again, you can just read your vertex. Your vertex is at -5, -23. Which you could verify if you put this into Desmos. Okay, I'll just summarize this. Completing the square is one strategy to go from standard form to vertex form. I'll show you another strategy in class known as partial factoring, but you know, this is a strategy. It's a good strategy, and it leads nicely into the next video, which I will do, which is on the quadratic formula. See you then.